You know, I was looking at the briefing for this deep dive last night.
Yeah.
And I was just sat at my kitchen table, just kind of flipping through the pages. And I had this distinct moment of, I guess you'd call it vertigo.
Vertigo, like the room was actually spinning.
Yeah, well, spiritual vertigo.
Yeah.
Because usually when we do these deep dives, we're talking about, I don't know, supply chain logistics or the latest LLM architecture, tangible stuff you can touch, you can code it. But today we are staring directly into the void.
And if the sources we're covering today are to be believed, the void is staring right back.
Please don't do that. That is absolutely terrifying.
It is a little bit, isn't it? But it's also weirdly hopeful. We are tackling a stack of research today, papers on pan-spatial cosmology, something called Finsler Coherence Hyperphase, and the mathematics of biologistics that fundamentally rewrites the entire story of how we got here.
And that story, the one we're all taught in high school biology, is essentially the lonely rock theory.
Right. The standard biochemical narrative.
Which goes something like this. The universe is a cold, dead, empty place. A bunch of rocks smashed together, some water pooled up, lightning struck a puddle of slime, and purely by accident, purely by a biochemical fluke, life happened. We are a mistake. A miraculous mistake, sure, but a mistake nonetheless.
A statistical error in a dead universe. That is the standard view. It's the view that says we are an anomaly.
But the sources we have today are flipping the table on that. They're arguing that life isn't an accident. They are saying life is a geometric inevitability.
That's the core thesis. That if you have a universe with the exact geometry ours has, life must emerge. It's not a roll of the dice. It's a feature of the board itself.
I want to start with a number from the intro packet because it really sets the stakes for why this new theory is even necessary. The Improbability Paradox.
Oh, right. The 10 to the 200 problem.
Yeah. Walk us through that, because I think people hear big numbers and they just glaze over. They hear billion and trillion and it all just sounds the same. But this number is offensive.
It really is. So standard evolutionary biology and chemistry have tried to calculate the odds of a single functional protein assembling by chance in a prebiotic soup. Just random atoms bouncing around, bumping into each other until they click into a working shape. The odds come out to roughly 1 in 10 to the power of 200.
Okay, 10 to the 200. Let's contextualize that for a second for everyone listening. How many atoms are in the entire observable universe?
About 10 to the power of 80.
So the odds of life happening by chance are exponentially worse than finding a single specific atom in the entire universe.
It's way worse than that. It's like winning the Powerball lottery every single day for 1 billion years consecutive. It's a number that, mathematically speaking, is indistinguishable from zero.
Yeah.
In any other field of science, if you got a probability of 1 in 10 to the 200, you would just say, this model is wrong. This cannot happen.
But here we are. I'm talking, you're listening. So obviously it did happen.
And that is the paradox. We exist, but our math says we shouldn't. So either we are the luckiest things that have ever existed, a miracle that defies all probability,
or the math is wrong.
Well, not necessarily the math itself, but the assumptions behind the math. The sources argue that we've been calculating the odds of life emerging in the wrong kind of space. We've been assuming we live in what they call dead space.
Dead space. This is a recurring term in the research, and it serves as the villain of this story, in a way.
Yes. This brings us to the first major section of our analysis, the failure of the Riemannian paradigm.
Okay, hold on. You're going to have to walk me through Riemannian paradigm. That sounds like a Robert Ludlum novel, The Riemannian Identity.
It does. Look, the foundation of modern physics, general relativity, Einstein, the whole deal is built on Riemannian geometry.
In plain English.
It's a model of space that is essentially smooth. Imagine a freshly resurfaced ice rink. Perfectly flat, perfectly smooth. If you slide a puck across it, it goes in a straight line unless something physically pushes it. It's a neutral background. It's just a container.
So in this view, space is just the box the universe comes in.
Exactly. It's passive. It doesn't do anything. It curves a little bit if you drop a heavy planet onto it. That's what we call gravity. But otherwise, it has no features. It has no grain.
So if I dump a bucket of Legos onto that ice rink, the ice rink isn't going to help build the Millennium Falcon.
Perfect analogy. The ice rink doesn't care about the Legos. They just sit there. That is dead space. And if you try to calculate the odds of those Legos assembling themselves into a spaceship on a frictionless, featureless ice rink, you get that 1 in 10 to the 200 number. It's never going to happen.
Because there's no force organizing them. There's no instruction manual hidden in the ice.
Right. So mainstream science tries to patch this massive hole with things like panspermia.
Which is the idea that, what, aliens dropped the Legos? Or meteors brought them?
That life came on a space rock from somewhere else. Life didn't start here. It started on Mars and hitched a ride. But you see the problem there.
Yeah, you're just kicking the can down the road.
Yeah.
How did life start on that rock?
Exactly. You haven't solved the improbability. You've just moved it to a different zip code. If space is dead everywhere, it doesn't matter where you start. You still have the exact same lottery ticket problem.
So the sources argue that the problem isn't the biology. The problem isn't the chemistry. The problem is the box. The problem is the space itself.
We need a new geometry entirely. We need to move from dead space to what the sources call living space, or, to use the technical term that's going to make you sound very smart at dinner parties, Finsler Coherence Hyperphase, or FCHP.
FCHP, Finsler Coherence Hyperphase. It sounds like something you'd divert power to in Star Trek when the shields are down.
It really does. Captain, the hyperphase is destabilizing, but it's actually based on very old, very rigorous math. It goes back to a guy named Paul Finsler.
Who was he?
A contemporary of Einstein. He wrote his dissertation in 1918. He proposed a geometry that was more generalized, more complex than what Einstein was using. But Einstein's model was simpler, it was more elegant, and it worked for things like calculating the orbit of Mercury. So Finsler kind of got left in the dusty corner of history.
The Betamax of physics.
In a way. But now people are dusting off Finsler's work because it can explain things of Einstein's geometry simply can't. Specifically, complexity.
So what is the fundamental difference? If Einstein's space is a smooth ice rink, what is FCHP space?
It's wood.
Wood.
Think about the difference between a block of glass and a block of wood. Glass is isotropic.
Isotropic, meaning?
Meaning it's the exact same in every direction.
Oh.
If you look left, right, up, down through glass, the structure is identical. Light travels through it the same way. It's directionless. That's Einstein's space.
Okay, and wood?
Wood is anisotropic. It has a grain. It has a direction. If you try to split a log, it's very easy to split with the grain and incredibly hard to split against the grain. The material itself has a preferred direction built right into it.
So FCHP suggests that empty space, the vacuum between the stars, has a grain?
Yes, space isn't empty. It has a flow. It has a structure. It has a preferred direction.
That breaks my brain a little bit, because if I'm floating in space, I don't feel a wind.
You don't feel it physically like a breeze on your face, but your atoms feel it. The subatomic particles that make up your body are constantly reacting to this grain in the vacuum. And this is where we get to the 4 pillars of living space.
Okay, let's drill into these, because the source document lists these 4 operators that exist in the vacuum. These are the tools that space uses to build life.
Right. These are the invisible hands molding the clay.
Pillar number 1, torsion, represented by the symbol sigma.
Torsion is the twist. In Einstein's relativity, gravity is just a curve. You put a bowling ball on a trampoline, the fabric dips. Things roll into the dip. Simple.
But no twist, it just goes down.
Correct. But in FCHP, space has inherent vorticity. It spins.
So it's not a trampoline. It's a whirlpool.
The whirlpool is a great visual. Imagine the vacuum of space is filled with these tiny, invisible whirlpools. Now, why does that matter for biology?
I'm guessing because biology loves spirals.
Biology is obsessed with spirals. DNA is a double helix. Proteins fold into alpha helices. Even at the macro scale, snail shells, hurricanes, galaxies, they all spiral.
In the standard model, we're told that DNA is a spiral just because, well, that's how the atoms fit together best. It's a chemical accident.
But FCHP says, no. The spiral shape exists in the vacuum before the molecule forms. The DNA is just filling a mold that space already created. The twist was there first. The atoms just got caught in the current.
Okay, that's a radical shift. You're saying the shape of my DNA isn't biological, it's cosmological.
It's geometric. The twisting force of the torsion literally wrung the atoms into that exact shape.
All right, pillar 2. Chirality, represented by chica, or handedness.
This is closely related to torsion. If you have a twist, you have a direction. Clockwise or counterclockwise, left or right.
Standard space is neutral, right? It doesn't care which way you turn.
Correct. In a dead universe, left and right are equal, but FCHP space creates a chirality flux. It breaks the symmetry. It says, we prefer left.
And this is huge for the mystery of homochirality, which I know we have a whole section on later, so I won't spoil it. But essentially, space has a bias.
It has a bias. It's pushing against the grain to go one way and with the grain to go the other.
Okay, pillar 3. Hyperfractal depth, script F. This sounds like a psychedelic rock band. We are hyperfractal depth.
It does. But fractal just means self-similarity at different scales. You know how a coastline looks jagged?
Yeah.
And if you zoom in on a rock on that coastline, it also looks jagged in the exact same way. And if you look at a tiny grain of sand, it's the same.
It's the Russian nesting doll effect. The pattern repeats.
Exactly. Now, standard physics struggles with this. It likes things to be smooth. But biology is hyperfractal. The branching of your lungs looks exactly like the branching of a tree, which looks like the branching of a river delta, which looks like the branching of lightning.
And usually we say that's just efficient engineering. Nature likes that shape because it works.
But why does nature like that shape? The source argues that space itself has this recursive layering. Information is packed into the vacuum in these nested layers. So when life forms, it's just tracing those fractal patterns that are already there in the background.
It's painting by numbers, but the numbers are written on the fabric of reality.
Beautifully put. It explains why we see the same shapes in a microscopic neuron as we do in the cosmic web of giant galaxies. Same geometry, just a different scale.
And the fourth pillar, coherence gradients, delta C.
This is the engine. This is the battery. You can have all the spirals and fractals you want, but without energy, absolutely nothing moves.
We usually think of energy as heat or electricity, or like a granola bar.
In this context, think of it as flow. The source uses the phrase, life pulls coherence downhill.
Downhill.
Imagine a river flowing down a mountain. That water has energy. If you put a water wheel in it, the wheel spins. It captures the energy.
Okay.
In a dead space model, there is no river. It's a stagnant pond. Entropy increases, heat dissipates, everything dies. But in FCHP, the vacuum has coherence gradients. There are literal rivers of energy flowing through the geometry of empty space.
So life is the water wheel.
Life is the water wheel. It locates a gradient, a flow of coherence, and it builds a structure, a body, to capture that flow and maintain itself.
So if I can try to synthesize this aha moment, and correct me if I'm wrong here, because I'm trying to rewrite my entire understanding of physics on the fly.
Go for it. You're doing great.
The ingredients for life.
Yeah.
The spiral shape, which is torsion. The preference for left or right, which is chirality. The complex branching structure, fractals. And the need to consume energy, gradients. None of these are things that biology invented. These are things that exist in the empty room before the furniture even arrives.
Precisely. The geometry creates the house. Matter just moves in. And that is the huge ontological shift. We stop asking, how did atoms get smart enough to build a cell? And we start asking, how did the geometry of space force atoms into that specific shape?
Which brings us to the math. Because the source didn't just give us philosophy, they gave us an equation. The Biogenesis Equation.
They did. And I know you listening might get nervous when we start reading equations out loud, but this one is actually really elegant.
It's listed as sigma times chi times script F acting on delta C must be greater than gamma critical.
Let's break that down piece by piece.
This sigma is the twist.
Right. Torsion.
Chi is the handedness.
Yep. Directionality.
Script F is the fractal complexity.
The nesting depth.
So you multiply those three geometric forces together.
Yeah.
Twist, direction, complexity. And you apply them to delta C.
The river.
The energy flow.
Exactly. You have these structural forces acting on a flow of energy.
And if that combination is strong enough, if it's greater than gamma critical, what happens?
You get a phase transition.
Like water turning to ice.
That is the best analogy. Think about water. It's liquid, chaotic, molecules bouncing everywhere. But if you lower the temperature, change the environmental conditions suddenly, snap. It locks into a crystal structure. It becomes ice. It has order. It didn't evolve into ice. It transitioned.
So you're saying life is just space freezing?
In a sense, yes. When those geometric forces exceed the threshold, space freezes matter into a self-maintaining boundary. It locks the atoms into a coherent structure.
And that structure is a cell.
Or a proton. Or a star. Or a person. The source calls this an attractor.
An attractor. I've heard this term in chaos theory.
Right. Imagine you're rolling a ball across a landscape. If there's a valley, the ball will eventually roll into the bottom of the valley and just stay there. It doesn't choose to go there. The geometry pulls it there.
So life is the valley.
Life is the attractor. The reason we are here isn't because we got incredibly lucky, is because the geometry of the universe is shaped like a funnel, and we slid down right to the bottom.
That makes me feel incredibly small, but
Yeah.
also incredibly secure. Like, we didn't just fall off a truck. We fell into a groove.
We fit. We fit perfectly. And this leads to a really controversial definition of alive that the source proposes.
Oh, yeah, the proto-life concept.
They completely redefine life. Instead of asking, does it reproduce? Does it have DNA? They say life equals identity plus boundary maintenance plus gradient flow.
So do you have a border? Do you keep yourself separate from the outside? And do you pull energy in?
If yes, you are alive.
And under that definition, a proton is alive.
It maintains a boundary. It persists for billions of years. It has an identity. The source argues a proton is minimally alive.
That sounds almost like panpsychism, like everything has a soul.
It borders on it. But it's distinct because it's not about consciousness or a soul in a mystical sense. It's about coherence. It's about maintaining order against the chaos.
So a cell is just mid-scale life.
And a galaxy.
Macro-scale life.
Exactly. A galaxy has a center, it has spiral arms torsion, it processes energy, it maintains a boundary. It is literally an organ of the universe.
I need to take a second. Because usually when I look at a galaxy, I see a massive collection of dead stars. But you're telling me I should be looking at it like I look at a jellyfish.
It's the same geometry, just scaled up by a factor of 1 trillion. It's the same wind blowing the exact same patterns.
This really reframes everything, but I want to ground this again. Because we have this massive claim that space forces life into specific shapes. And there's one specific shape, one specific mystery that has stumped biologists for 100 years. And this theory claims to finally solve it.
You're talking about the left hand of God.
I'm talking about chirality. Why is all life left-handed? Let's slide right into section 4, the mystery of chirality.
Let's do it.
Explain the problem first. If I go into a lab today and I mix up the chemicals to make amino acids, the building blocks of life, what happens?
If you do it in a test tube, you get a racemic mixture.
Racemic.
That means 50-50.
Yeah.
50% of the molecules twist to the left, 50% twist to the right. It's a coin flip. Chemistry doesn't care. It has absolutely no preference.
Okay, so basic chemistry says 50-50. But if I look at a tree, or bacteria, or you.
100% left-handed amino acids.
100%, not 51%.
Pure homochiral. If you try to feed a human body a right-handed amino acid, your body can't even use it. It might even be toxic. Our biology is strictly, exclusively left-handed, and our sugars, strictly right-handed.
Why?
That is the million-dollar question. Standard science says it was an accident.
The frozen accident theory.
Right. The idea is that the very first cell just happened to be left-handed. It ate all the food, reproduced, and killed off any right-handed competitors. It was a winner-take-all scenario based on a random coin flip 4 billion years ago.
But the FCHP framework says, no, the coin was rigged.
The coin was heavily weighted. Remember the torsion, the twist in space?
The wind.
The wind. The source describes a chirality cascade. Because space itself has a preferred direction, that anisotropy we talked about, it exerts a tiny, tiny pressure on molecules as they are forming.
A pressure to go left.
Exactly. Now, at the quantum level, this pressure is minuscule. But remember the hyperfractal part, the nesting dolls.
It amplifies it.
It's recursive. It loops. That tiny bias gets multiplied over and over and over again until, boom, you get 100% left-handedness.
So it's not an accident. It's geometric determinism.
And here's the kicker. Here's the prediction that makes this theory actually testable.
Let's hear it.
If this is true, if space itself dictates the shape, then all life in the entire universe must be left-handed.
All of it.
Everywhere. If we go to Alpha Centauri and find slime mold, left-handed.
Mm-hmm.
If we find little green men in the Andromeda Galaxy, left-handed.
That is a massive gamble. Because if the frozen accident theory is right, then the aliens in Andromeda could be right-handed. It's a 50-50 shot.
Exactly. Standard science says we don't know what aliens will look like. Panspatial cosmology says we know exactly what their proteins look like.
And if we find one right-handed alien...
The theory is dead. It's completely falsified. It relies on universality.
I love a theory that actually puts its neck on the line. But let's move from the aliens back to our own bodies. Section 5 describes biologistics.
This is where we take the abstract math and apply it to the wet, squishy stuff.
The sources use the phrase biology as materialized geometry.
It means that everything your body does, beating your heart, thinking a thought, digesting a sandwich, isn't just chemistry, it's geometry.
Let's talk about metabolism. We usually think of the Krebs cycle, enzymes breaking down sugar.
But why does it work? Biologistics says metabolism is derived from laminar turbulent phase transitions.
Whoa. Unpack that for us.
Okay. Think about a smooth flow of water. That's laminar. Then think of a rapid, chaotic splash. That's turbulent. Life exists on the razor's edge between those two. Metabolism is basically harvesting turbulence. It's taking a flow of energy, creating a controlled chaotic burst to capture coherence, and then returning to a smooth flow.
So we eat chaos for breakfast.
Controlled chaos. If it was too chaotic, you'd explode. If it was too smooth, you'd be dead. Life surfs the edge.
And what about the brain? Neural signaling.
This one is fascinating. The source says synaptic plasticity, the way our brains learn and rewire themselves, is actually torsional strain in the coherence boundaries of the neurons.
So a thought isn't just an electrical spark.
It's a twist, a geometric twist in the boundary of the neuron. When you learn something new, you are physically altering the geometry of your coherence field.
And evolution itself. We usually think random mutation plus natural selection.
FCHP rebrands evolution entirely as a recursive boundary optimization.
Which means
It means life isn't just randomly mutating and hoping for the best. It's constantly trying to find the perfect geometric shape to maximize the flow of coherence. It's trying to become a better water wheel.
it's trying to fit the mold of the universe better.
Exactly.
This has major implications for astrobiology. If we are looking for life out there, where should we look?
The old view, the NASA view, typically is follow the water. We look for Goldilocks zones. Not too hot, not too cold.
But the new view, the FCHP view.
Look for high torsion and gradients. The theory suggests life doesn't need a nice, calm, planetary pond. Life needs energy flow.
The sources list some surprising locations. Molecular clouds, stellar interiors, even the hypercores of quasars.
Life inside a star.
You tell me, is it possible?
Well, if life is just a self-maintaining boundary harvesting a gradient, a star has massive gradients. The source explicitly states life might exist in inhospitable plasmas or vacuum phase transitions.
So we might be staring at life forms through our telescopes right now and thinking they were just astrophysical anomalies.
We're looking for biology as we know it, carbon and water. But if life is geometry, it can be made of plasma. It can be made of purely magnetic fields.
That is terrifying and awesome. But again, I'm the skeptic here. I want receipts. Section 6 is testing the theory. How do we prove this isn't just a nice sci-fi story?
The sources are very specific here, which is refreshing. They provide a concrete list of falsification criteria.
Let's run through them. Prediction 1, extraterrestrial organics.
We touched on this, asteroids like Bennu. We've brought samples back. The prediction is that the amino acids found on these asteroids must show the exact same Earth-like chirality, left-handed.
We're still analyzing those samples in labs right now, so that's a massive cliffhanger.
It is. If they come back 50-50, FCHP takes a massive hit.
Prediction 2, gravitational waves.
This involves LIGO. Standard general relativity says gravitational waves are just ripples in space-time, stretching and squeezing.
But FCHP predicts
Torsional polarization. Basically, the waves should have a twist to them that Einstein didn't predict. They should spiral as they travel.
Can LIGO actually detect that?
With the next generation of upgrades, yes. If we see a screw-like motion in the gravitational waves, that essentially proves space has torsion.
Prediction 3, cosmology.
This one is about the big picture. The hyperfractal nature of space means that the distribution of galaxies shouldn't be random. It should look fractal like a giant web up to huge scales, like 600 million light years.
And current surveys like DSI and Euclid are mapping this right now.
And early data is actually leaning toward fractality. The universe is looking more and more like a sponge or a neural network than a random scattering of dust.
And prediction 4, lifeless clouds.
This is the idea that we should find complex organic molecules in the middle of absolute nowhere. The source mentions the Sagittarius B2 molecular cloud.
This is deep space, freezing cold, no planets anywhere.
Exactly. But if space creates life, then the seeds complex, chiral organics, should be forming in the vacuum itself. We should be detecting things like pyrene and amino acids in these clouds using the James Webb Space Telescope.
And if we find them?
It means the universe is a factory. It's churning out the building blocks of life everywhere, all the time, regardless of whether a planet is nearby.
Okay, let's zoom out even further. Section 7, relativity, gravity, and the bigger picture. The source mentions something called the Randers metric.
This is where FCHP tries to unify biology with physics. In standard cosmology, we have dark energy, this mysterious force pushing the universe apart. We don't know what it is, we just know it's there.
It's the placeholder name for, we have no idea why the universe is exploding.
Exactly. But FCHP says dark energy isn't a mysterious force at all. It is torsional stress.
Torsional stress.
Imagine twisting a rubber band. As you twist it, it gets tight. It creates tension. The theory argues that the twisting of space itself, that torsion we talked about, creates an outward pressure.
So the universe is expanding just because it's twisting.
Yes. And the source claims this resolves the cosmological constant problem without needing fine-tuning. It's just a property of the geometry. The universe spins, so it expands.
And this ties into the Fermi paradox. Where is everybody?
This is honestly my favorite part of the entire theory. If life is inevitable, if it's everywhere, why haven't we heard from anyone? Why is the radio totally silent?
The usual answer is they blew themselves up or space is just too big.
The panspatial answer is ascension, but not in a religious sense, in a purely geometric sense.
Explain that.
The argument is that advanced life integrates into the coherence geometry itself. Remember, life is about boundary maintenance and flow. At a certain level of advancement, you don't need a biological body made of meat and bone.
You transcend the meat suit.
You realize the meat suit is incredibly inefficient. You can maintain your identity and coherence as a structure within the spatial fabric itself.
So they become part of the background physics.
They become non-material boundary states. They aren't hiding on planets. They are part of the spatial structure. Our sensors, which are built on Riemannian dead space physics, can't see them because we're looking for radio waves or heat signatures.
We're looking for campfires, and they have literally become the wind.
That is a very poetic way to put it. The source literally says they don't need to travel. The universe is the organism.
That implies that we are like bacteria living in the gut of a giant being, wondering if we're alone.
And the giant being is the geometry of space-time itself.
That is profound. And it brings us to the final philosophical conclusion in Section 8, the ontology.
This is the summary statement of the entire framework. Life does not emerge in space. Life emerges as space.
That distinction is everything.
It changes us from being inhabitants to being expressions. Matter is just solidified space. Biology is just slowed down coherence dynamics. We are the universe recognizing itself.
It really hits you on an emotional level. I mean, I started this deep dive feeling vertigo. I felt small. I felt like a mistake.
And now?
Now I feel necessary. If this is true, we aren't a fluke. We aren't a mistake. We are a geometric inevitability.
We belong here. The math says we have to be here. The universe would be fundamentally incomplete without the twist that makes us.
So as we wrap up this deep dive, I want to leave you listening with a final provocative thought. The next time you look up at the night sky, look at the empty parts, the black parts between the stars.
Don't see it as nothing.
Right. Don't see it as a vacuum. Don't see it as a cold, dead box. See it as a churning, twisting engine, a machine that is constantly trying to spin itself into life. That empty space is the most alive thing there is.
And keep an eye on the news. Seriously. If you see a headline about chiral molecules in molecular clouds or torsional signatures in gravitational waves,
that's the smoking gun.
That's the signal that the universe is alive.
Thank you for joining us on this trip through the geometry of life. This has been The Deep Dive. We'll see you next time.
See you then.